Okay, so page 455, number 51. Again, still verifying the identity. This one says secant to the fourth minus tan to the fourth is supposed to equal 1 plus 2 tan squared. So I'm going to work on the left side. Again, there's not much to do on the right side. But here I have something to the fourth minus something else to the fourth. That's just like difference of two squareds, right? So I'm going to take what I have and factor it. But I do want to mention that there is a relationship between secant squared and tan squared, right? From the identities. If we go back to section 1, we know that 1 plus tan squared, and just put theta, equals secant squared. Okay, and we can rewrite that a little bit. We might use that. We might have, since I have a secant minus a tan, if I put those together, I have that 1 equals, I'm going to subtract tan from both sides. I get secant squared minus tan squared. Any variation of these guys, and there's another one that I could create, but any variation of this identity, this Pythagorean identity, we can use. So let's start on the left side. Let's factor. It's like I have something squared minus something else squared. Difference of two squareds means I have the first one minus the second one times the first squared term plus the second squared term. Right? And if you don't see that, you can think of it as A and B, right? If I had, I'll just write it up here. If I had A squared minus B squared, that would just be A minus B times A plus B. But when I have it, oops, this is supposed to be squared. But when I have it to the fourth power, I'm thinking of that fourth power as A squared to the second power. So instead of A minus B, it's going to be A squared minus B squared and A squared plus B squared. So difference of squares, we could break this down even more, but difference of squares actually works for any even power there. As long as they're kind of even powers, we're good to go. So I have secant squared minus tan squared and secant squared plus tan squared. And I did say that we can use any variation of the identity, and we already have one right here. We know that secant squared minus tan squared is 1, so I'm actually going to rewrite this as just 1 times what I have here. Secant squared plus, theta, plus tan squared, theta. Now I still don't have what I want because I'm supposed to get 1 plus 2 tan squared, but I have almost what I need, and this secant I'm going to have to take out because what I eventually want is just tangent. Right, so I come back over here and say, well, there's another form of this same identity that I can use again. Secant squared is equal to 1 plus tan squared. So right now I have secant squared plus tan squared, but I can rewrite that as this is the same thing as 1 plus tan squared. And then I'm just dropping this tan squared down. Right, now I have all tans. I don't have any other trig identity, and I have 1 plus a tan squared plus another tan squared. That's going to be 1 plus 2 tan squared. And now my left and right side are congruent.